Hi. Today we are on the lab uh, of the IoT simulation, and we are doing it on Walkme. Okay? So browse your browser to walkme.com or just search uh, on any search engine for Walkme. Okay? And the reason that we are using Walkme for this class, for this week, is that Walkme is a simulator that uh, is a bit advanced and provide you the Wi-Fi connectivity simulation. And yeah, that's going to be used in the IoT also. So that's why we are doing it on Walkme. Yeah, so let's start. On the Walkme, there are many of the devices uh, for you to select. And for our class, I expected to use the one from Expressive. Uh, so actually, it has the ESP8266, the decent one, and another one, the newer. It is called the ESP32. So tap on the ESP32, and there are many of projects uh, already prepared uh, for you to study and present you with um, the sample code. Okay, so you could study right there. By the way, I'll keep stick with the starter templates. Okay, and the one that are going to be used for today is the ESP32. By the way, there are much more. For example, ESP32C3 or something else. And there are differences in the architecture that are uh, that, that that is used in the microcontroller. So okay, let's try ESP32. You get one little board of the ESP32, and before we are doing, we will connect the circuit uh, on the right hand side before we are doing the code on the left hand side. So tap on the add button, the plus button, okay? And search for the breadboard. There are many of size. Sorry, yeah, breadboard. I'll use the half size, two of them, two half size, and make it a little bit overlap. Okay, this is because we are going to uh, test our devices on to this board. Once you have it, um, tap on the R button to rotate and then place it. Okay, just like that. Okay, and then have a resistor connected to pin 14. You are free to select any pins, okay? But don't forget to have a look on some reference or documentation or data sheets of the microcontroller first. This is because some of the pins are not uh, are possible to be used as a GPIO. We already did the calculation in the class that it is 200 ohms to drive LED. Okay. The LED has two pins, okay, and it could not be switched. Okay. The anode pin, the one with the letter A, and another pin is the cathode with the letter C. So the anode pin connected with the resistor, and the cathode connected to the ground. You could tap on the wire to change their colors or to move or adjust or bending them. Okay, and so it depends on. And once I have it in the program, I'll use the constant integer to save the pin number. So it is the LED connected to pin 14. And in the setup function, you have to set the mode of the pin because it is a general purpose IO. So that means you could set it to be both input and output. I mean, for some pins. So call the pin mode function on the LED and make it output. Yeah, because we are generating the voltage from the microcontroller to drive the LED. So that's why. And in the loop, you could use the digital write function to set the pin uh, to some logic you want. For example, you could set the LED to be high. Don't remove the delay 10. This is used to speed up the simulation. This is because the simulation runs and getting pause and doing the animation every 10 milliseconds on the start simulation. It might take times and sometimes the building queue is so long and you have to have it more than once. Fortunately, I got it in the uh, first try. Here's the result when you are setting the pin 14 to be high. So the LED is glowing. And yeah, you might have known that if I set it to be low, so it will be turned off. But instead of that, I would write a program to make a delay of 500 milliseconds, okay, and set it to be low for another 500 milliseconds. So the program will make the LED turns on for 500 milliseconds and then turns off for another 500 milliseconds. So it's it making the LED blink. Yeah. So that's how you manipulate the output pins and just using the digital write function. And now for the input, I will place a push button just right here. It could be elsewhere on the breadboard. Doesn't matter as long as you connect the circuit properly. Okay? This switch is not, and also the LED is not in the reference of the walkway, so we don't know exactly how it works. By the way, this is the single pole control. That means you have only one uh, uh, part of the sorry one part of the connections. Okay? Mm. And to safely use the push button, I mean for a single pole control, it is safely to uh, have the wires from the top left and the bottom right, or maybe the one other side across. Okay, this is because uh, the one in adjacent, for example, the side, maybe this side or maybe this side, is already connected inside. Okay, so it is safely to use it across, okay, to prevent the improperly connections in the circuit. Okay. To use the push button, I will use 1 kilo ohm connected to the 3.3 volts. Okay. And in between, I mean the pins that are sharing with the sharing between the resistors and the uh, push button switch is going into the microcontroller. I'll use pin number 27 for this task, and you could move or bend the wire. Okay. And on the bottom right would be connected to the ground. Okay. So let's have a look at the circuit a little bit. If the switch is not pressed, so it is not connected, that means 3.3 volts are going through the resistor, okay? And going through the yellow wire to the microcontroller on pin 27. And because the push button is not pressed, so it's not related to the one across. By the way, if the switch is pressing, that means no matter how the 3.3 volts up here is connecting, okay, the pin number 27 is going to pull down through the push button to the ground. So that make the pin number 27 be 0 volts at that point. Okay? And the 3.3 volts is going to dissipate the energy through this resistor in the heat form. So it is best to use as least, uh, 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 sorry, I would say at most uh, resistance as possible uh, to do this job. Okay? Because uh, when it is pressed, uh, it would draw currents and dissipating in heat, and that's kind of energy loss. Okay. Yeah, and to use this button, you might notice that it has the bounce stick right here. The switch has a bounce. Uh, it happens when the finger is releasing from the button, and inside the button there are springs. Okay? So it will keep changing for a little while between press and not press. Okay? So press and not press, press and not press, because of the spring inside the button. So that's called the bouncing, and we have a way to prevent that. It is called debouncing, and we will learn it shortly after uh, uh, some lecture. Okay. By the way, just now, let's do the program by setting a constant integer on the switch, and it is connected to the pin number 27 and have the pin mode of the switch. We are using it to be an input. Okay? And the difference between input, I mean the plain one, and the input pull up is that the input has the open drain or open collector configuration, just as in our lecture slide. But for the input pull up, the microcontroller will have a pull up resistor connected inside. So for this case, we already connect the 1 kilo ohm resistor outside. So there are no reason to use the pull up inside. So set it as a plain input. Okay. Okay, and I already depict you that if the switch is pressed, then when you read the switch by using the digital read function from the switch, and it is high, that means it is not pressed. Okay? So you could do anything uh, for that case. For example, you could turn the LED off. Otherwise, if the switch is pressing, so digital write on the LED to be high, the slowing. Okay, so that's the program that we just uh, made use of the uh, switch, and I'll try uh, the simulation. And this time it took so long. Maybe I have to recompile the project. No? Okay. Fortunately, it is uh, working in the first run. So now, 3.3 volts is going through the resistor and going to the pin number 27 of the microcontroller, and that's make the LED off. Okay? But once I press the button, the pin number 27 is going to pull down to the ground and make it zero or make it low. So the LED is glowing. So because we are writing it to be high on on the code line number 13. Okay. So that's how you manipulate with the digital um, side of the microcontroller. I mean the GPIO. uh, and you could practice with something else. For example, once you pressing the button, uh, you could make one LED glowing and another going off, and uh, switch the the LED once it is pressed. Uh, for example, or you could try with other devices. For example, you could doing it the 7 segment or using the LED bar graph. Okay? And there are IR receiver or IR remote with the keypad. These are uh, usable with the digital logic. Okay? By the way, the rest of that, uh, some of them might not be easily. Okay? Um, or you could try with the buzzer, but most of the case you need to produce the frequency out to the buzzer, so you could switch on and off. And the relay module to have the circuitry separated from the Arduino to make the Arduino safe uh, from the rest of the circuit. It has the logic analyzer, so you could try uh, tracking uh, the digital logic from wires or pins, or you could practice with the logic gates. Yeah, and that's the digital part of uh, the microcontroller. But I hope that uh, you practice uh, on the walkway with other devices to make you familiar with the uh, digital um, manipulation. Okay? And on the next week, we will doing the lab on the analog, and we will try with some sensors. I mean the real ones that are using in many projects. So yeah, and wish you have a nice weekend and see you on the next week. Catch you.